Hello, everybody out there in Math 150. We're going to be looking at section 3.2 today. Our first learning objective is using the remainder theorem and factor theorems. It sounds kind of scary, but it's really not that bad if we just break it down. But the first thing I need you to remember is, do you remember how to do polynomial division? Okay, because we're going to be using that quite a bit. Polynomial division, it works like this. We've been talking about polynomials the last couple of sessions, and we've got a polynomial of degree 3 in the numerator, and we're dividing it by a polynomial of degree 1 in the denominator. That means we can rewrite this using long division. So the idea here is to use long division to go and actually figure out the answer to this question. So you may have learned long division or something called synthetic division. We're going to look at both of them really quickly. You're allowed to use either one, whichever one you prefer. So the way I do long division is this way. I'm always trying to eliminate the leading term right here. So the question is, what do I multiply x by to get x cubed? And that's the way you want to ask it. What do I multiply this by to get this? So in this case, what do I multiply x by to get x cubed? So in this case, we would multiply that by x squared. So now you have to distribute that x squared to both of these terms, and that's going to give you x times x squared, which is x cubed. It's going to give you -1 times x squared, which is -x squared. Now, this is the real moment of truth here, because this is where so many people make the mistake. I'm going to change my colors to really emphasize this. What we want to do is we want to subtract these two things, but the way we're going to say it is we're going to change all the signs and add them. By using a different color, I'll change that to a negative, I'll change that to a positive, and that will remind me that I've changed all the signs, because so many people do the first sign and forget about the second one. So now when I add these together, going down right here, I'm going to get 0. But over here, I'm going to get -4x squared. And I'm going to bring that down and have -4x squared. And you may remember now is the appropriate time to bring down the next term, -4x, and we're going to start this game all over again. What do we multiply x by to get -4x squared? That's the question. X to get -4x squared. And the answer there is -4x. So again, we're going to distribute, and we're going to get -4x times that x right here. That's going to give us -4x squared. And now we're going to multiply this -4x times this -1, and that's going to give us +4x. So again, the thing you want to remember at this point is we are going to change the signs and add. So I'm going to take that negative and make it into a positive. I'm going to take this positive and make it into a negative. And now I'm going to add these columns together. The x squareds are going to go away, and we're going to be left with -8x. So now we bring down the 9, and we're going to have -8x plus 9. Again, what do I multiply this x by to make -8x? So that's going to be -8. And now we want to distribute that. -8 times that x is going to get us -8x. And then we're going to do that -8 times that -1, and that's going to give us +8. At this point in time, we do it again. We change the signs and add. And when we do that, we end up with a +1. What that means is we have a remainder of +1. The way we would write that is we would say that the remainder is, in grade school, when you learn about, you write R1 there for remainder of 1. What we're really going to do is we're going to write that a little more mathematically. We're going to say that we're left with this remainder of 1, which means that I've got to add the next term of our remainder of 1 over our x minus 1. And that is where we are going to get the results of this question. Okay, so there's the remainder. So moving down, here we go. We just looked at polynomial long division and got the answer for this first one. And again, I'll just copy that answer down so we have it. So here we go. Let's copy that. And that's what we got for this answer. Now I'm going to remind you of your synthetic division. You may or may not remember this. Basically, all you do is you set up the coefficients. So there's my 1, there's my -5, there's my -4, and there's my 9. And then we're dividing by x minus 1. We always use the other sign. This says -1. We're using 1 because we're really using what makes this expression equal to 0. So we're doing it by 1 because that's what makes this expression equal to 0. You always start by bringing down the first number like this, and then this is the way it works. You do this number 1 times 1, and then you write it here in the next spot, okay? So 1 times 1, you get 1. You write underneath the 5. From there, what you do is you add that column. So when you add this, you get -4. So now you're going to do the 1 times -4. And when you do that, you write it up here. And then you're going to add that column. And that's where you get -8. So now you're going to do the 1 times -8. And that puts -8 up there. And now you add that column. And when you add this column, it's your last column, this will be your remainder. So you've got a remainder of 1. So now how do you decipher this? Well, this number right here is basically the C value. This is the B value. This is the A value. Or that's from using the quadratic formula. If you're using our polynomial notation, this is A sub 0, this is A sub 1, this is A sub 2. So remember, A sub 2 goes with the x squared, A sub 1 goes with the x, A sub 0 is the constant by itself. So that would get us 1x squared minus 4x minus 8. And then our remainder would be the 1 over x minus 1. So we will get the same answer. So if you're more familiar with synthetic division, feel free to use synthetic division on all of these problems. So that's just a little review on how to divide polynomials, whether you use long division or synthetic division. We need to understand this because we're talking about the remainder theorem today. And when you're talking about the remainder, you're talking about division. So if f is a polynomial, let f be a polynomial function. So one of our friends from the last section. If f is divided by the factor x minus c, the remainder is actually f of c. Now what that means is we can predict the remainder before we even start. Okay, so the remainder is found by f of c. Let's take a look at this. All right, we want to know what the remainder would be in this problem if we went and we divided x cubed plus 5x squared minus 4x minus 2. And we want to divide that by x minus 1. Okay, now we could go through this whole process, and when we're done down here, we'd find some little remainder down there. But all we're doing is just trying to find out what the remainder is. So the theorem says, find out what f of c is from looking at x minus c. Well, x minus c is the number that we plug into the factor. Okay, c is the number that we plug in to make this 0. C is the number we plug in to get 0 out. So in this case, since we're dealing with x minus 1, c is going to be 1. So we know that c is equal to 1 in this problem. If we find f of c, that's the same as finding f of 1. Well, in this problem, when I plug in f of something is equal to something cubed plus 5 something squared minus 4 times something minus 2, if I plug in my 1, what I'm going to end up with is 1 plus 5 minus 4 minus 2. That gives us an answer of 0. So we're going to find out that there is no remainder. This is going to go in evenly. So let's check this out using synthetic division on this one, okay? So let's set up the synthetic division. We want to divide by x minus 1, which means we're going to put a 1 on the outside. Our coefficients are 1, 5, -4, and -2. And again, I'm getting those coefficients from here. And what goes on the outside is what makes this guy 0. So that's why that's 1. So now if we set this up using the synthetic division, the way it's going to look, we always bring down the first number. And now we say this times this. So 1 times 1. And we write it here. Then we add that column. So we get 6. So now we're going to do this 1 times this 6. That's going to get us 6. And now we add that column. And that's going to get us 2. Then we're going to do this 1 times this 2, and that's going to get us 2. And then we add that column, and jackpot, we get 0. That's the remainder. The remainder is 0. So remember, this is your a sub 0 right here. This is your a sub 1 and your a sub 2 when we're talking polynomials. So what we're going to say is that we're going to end up with x squared, or 1x squared, plus 6x plus 2, and no remainder. So again, the bottom line is if you want to see if there's a remainder, plug in the number that makes the factor 0. That will tell you your remainder every time. So when we look at this example, okay, x plus 5 is our factor, which means our C value equals -5, because that's what we've got to plug in to make this 0. To find the remainder, the theorem tells us take your function, set up your somethings. So it's going to be something cubed minus 6 times something plus 3. We're now going to plug in -5 everywhere. And when we do that, we're going to get -5 cubed is -125. -6 times -5 is +30. And this is going to be +3. So this is going to give us, let's see, 125, -125 plus 30. That's going to take us -95. -95 plus 3 is going to be a -92. -92 will be the remainder. -92 will be the remainder. All right, so that's the remainder theorem. If you're ever asked, find the remainder, look at what makes this factor equal to 0 and then plug that in. Whatever factor makes this equal to, I'm sorry, whatever number makes this factor equal to 0, that's what we plug into the function. So in this case, it was -5. When we plug -5 in, the remainder ends up being whatever that output is. Next thing we're looking at is the factor theorem. We've talked about this in the previous section. If f is a polynomial function, we know that x minus c is a factor if when we plug in c, we get out 0. That's just a consequence of what we just said, okay? If I plug in c and get out 0, there is no remainder, so our factor goes in evenly. So let's test this out on a couple of examples. Use the factor theorem to find if x minus c is a factor of f of x. So in this case, our c value, this tells us c is equal to 2 because that's what makes x minus 2 0. So when we plug in 2, let's plug in our 2. If this equals 0, we're going to get no remainder. So 2 to the 4th is 16. 16 times 4 is 64. 2 squared is 4. -15 makes -60. And then we subtract 4, and sure enough, that equals 0. So x minus 2 is a factor of 4x to the 4th minus 15x squared minus 4. We could then use long division or synthetic division to find our other factors. Let's test the next one. Here, if x plus 1 is the factor, c equals -1, because that's what will make it 0. So let's plug this in. So as we plug in, we're going to get all of our somethings in place. So in goes my -1s. So what we're going to end up here with is -4. This is going to be -3. This is going to be +8. And this is going to be +4. Okay? So when we do all this out, we end up with -7 plus 11. That's going to be 4. So this means 4, I'm sorry, let me rework that. I think I said something different than what I just wrote. So we're going to end up with -7 plus 12, and that means we're going to end up with 5 as our result, okay? So 5 does not equal 0, so we have a remainder of 5. So x plus 1 is not a factor of our original function, 4x cubed minus 3x squared minus 8x plus 4. The last thing we want to look at for today in this particular unit is the last theorem. It says a polynomial function cannot have more real zeros than its degree. What that means is if I have f of x equals x squared minus 6x plus 5, the degree here is 2. What that means is the most solutions we can have to this equation is 2 solutions. The maximum number of solutions to this equation is the same as the degree. Now you could have less. You could always have less than your degree, but you can't have more. So when we go to solve this, we know that if we find 2 solutions, that's going to be the end of it. In this case, you're going to find that this factors very nicely right away, x minus 5 and x minus 1. So you can see that you get one solution of x equals 5. You get another solution of x equals 1. So those are the theorems that we're looking at in this particular unit. I'll be back in a little bit to talk about the next learning objective from this chapter.